Okay. Hello, everyone. I am Marios Kyriakou. I'm a researcher at QGIS Research Center of Excellence, University of Cyprus. And I will present the QSU2, a QGIS processing plugin to prepare the SU2 files for CFD simulations. QGIS Research Center and, QGIS Research Center and Innovation. QGIS Research and Innovation Center of Excellence has extensive knowledge and expertise in smart water systems and has led several important projects related to water contamination risk assessment and emergency response. One of these projects is the Horizon 2020 Pathogen Contamination Emergency Response Technologies, the PATHOCERT project, in which different tools have been developed for situational awareness and response to contamination events. One of our tools, the PathoInvest, has won the Digital Water Award 2024 by Water Innovation Europe. QGIS SU2 dynamic coupling architecture is incorporated in PathoInvest and used for the preparation and implementation of the boundary conditions into the SU2 model. This architecture has been tested as part of the PATHOCERT project and applied to simulate water pollution in the Panjarevon Dam in Sofia and Yermasoya Dam in Limassol. Our aim was development of a user-friendly coupling architecture that enables the fast and efficient preparation of accurate and reliable mesh and boundary files through QGIS, allowing seamless integration into the SU2 software. In order to achieve that, we follow the following objectives. Development of QGIS processing plugin for the preparation of the boundary and mesh files, testing and validation of SU2 against real case, useful for emergency response and rapid risk assessment. QSU2 can be integrated as part of a digital twin solution. The system architecture consists of three different subsystems. The first one is the SU2 files preparation, which is the required boundary and mesh files are prepared in QGIS using the QSU2 plugin. The second one, the simulation, files are transferred to SU2, which run till the solution is converged. And the last one, the results are post-processed, exported as vectors, CSVs, images, and animation files. So now I will do an introduction to different tools. What is GIS, Geographic Information System? A special system designed to create, store, and manipulate, analyze, manage, and maps of all types of data. Everyone knows the directions in Google Maps, like the GIS. And we select the QGIS because it's GIS software, many different GIS applications available, like ArcGIS, MapInfo, and so on. Some cost tens of thousands, but QGIS is completely free. And like SU2, if you need extra functionality, you can use or create a plugin. It's constantly developing. Extensive help and documentation online, cross-platform, Windows, Linux, MacOS. QSU2 plugin is an open source QGIS processing plugin developed by QSU2 for the purposes of the PathoCERT project, integrated in the awarded PathoInvest. Efficient preparation of mesh and boundary files for SU2 using geographical data, has more than 500 downloads at the time. To use QSU2, you can use the processing toolbox in QGIS. Just search SU2 and allows the user to easily create the mesh, export boundary files, run simulation, and visualize the solution. For the functionalities of the QSU2, we can load GIS data. Figures shows an example of the Germasoia Dam in Limassol, Cyprus, important for exporting accurate geometrical information of the domain. The mesh layer creation functionality. User can import the geometrical layer loaded from GIS as the input layer to select the number of nodes and perform the mesh operation. For example, for the Germasoia Dam, images on the right side with 100,000 nodes have been selected. Inlet-outlet boundaries layers creation functionality. User can choose the location of the inlet and outlet boundaries on the created mesh file. Design the shape of both inlet and outlet boundaries on the map. Perform the create boundaries operation. An example is presented in the figure for Germasoia Dam, inlet layer in orange color and outlet layer in the blue color. User can easily export the files and save them in the directory of his preferences to be used by the SU2 simulation. Also, we have the run SU2 simulation. User can select the executable or in future the Python, directly the Python version of SU2 CFD. They input and configuration files through the parameters tab and select run. At the same time, the user can see the logs of the simulation. We have the results post-processing, which includes the CSV files at different iterations. We can see on the right the CSV file, and user can select the parameter of interest to be plotted on the QGIS map. The plugin allows also the creation of an animation GIF file by selection of the directory of the results files, choose the parameter of interest, choose the duration period of the frames, and execute the operation. Now, the use case from Pathos project, we have two scenarios. The first scenario, in Germasoia Dam, a tanker truck with unknown liquid cargo, possibly contaminated with storage, falls into the reservoir after a collision with another vehicle. Its content is released in the water. First responders need to search and rescue for survivors. And the scenario 2, a contamination event is occurring in Pangarevo Dam due to flooding of storage water. And we can see the two images for the Germasoia and Pangarevo dams. SU2 methodology submodels, K omega SST turbulent model, incompressible flow, flow as a pollutant, runs as the solver, multiple species water and pollutant, numerical method gradient, the weighted least squares, mesh size 81,000 of cells and 9,000 iterations. And here we have the results of our dams for specific iterations, and user can see the spread of the contamination in the dam. And here is the GIF file for the Germasoia and Pangarevo. You can see also the animation of the contaminant. And conclusions and future work, plugin up, advanced config editing options, provide users with more flexibility to edit additional parameters directly with the config file. Introduce new algorithms, testing and validation with real data from other cases, deepen understanding of the SU2 CFD code base and its capabilities to further enhance QSU2 functionality. Contributions are welcome. And integrate QSU2 into the Cyprus digital twin platform. Thank you for.
Thank you very much. And again, the floor is open for questions. Let's go back to the serious conference mode. State your name and affiliation.
Hi, Gaito from Hawaii. Thank you very much for your presentation. So GIS gives you basically the geospatial data, but then we still need to create a mesh for SU2. So what is the mesh that you use?
I can't hear you.
Okay. The question of NASA was what kind of measure you use, because you need that. We can hear you. The problem is that probably you cannot hear me.
Can you hear me?
Oh, what happened? I didn't adjust anything.
Can
You
you
should
hear
be
me?
hearing us. Yeah, we can hear you. Can you hear us?
Yes, now yes. Tell me again, please.
Maybe
Because
Yes, I'll try again. Naisov Bosch was asking what kind of measure you use to create the mesh of the lakes.
the measure.
The meshing tool.
Grid generator.
Yeah, can we go to here? On
Yes.
slide 11, you're showing some grid generation. What are you using to generate that grid?
We have already algorithm in QSU2 to create the mesh
So
based on the GIS measurements.
So you have an in-house tool that does some kind of triangulation, for example? Like
Yeah.
the one?
In-house.
Yeah. No, not in-house. Also, I'm not also the developer of the mesh
Generator.
algorithm. So I'm not going to detail.
No problem.
We could try to look it up. Yeah.
There's another question here coming.
This
Yeah.
is from my studio. Regarding the evaluation of like real life test cases, this is also possible to visualize like the flow through a lake, for example, with like measurements of roads, or do you have to like flow simulation from uniform conditions?
Is question clear?
No, I'm not. It's not clear in my.
So how about the initialization? Are you able to initialize from, say, a known flow pattern in the lake, or do you have to use uniform initialization?
To select just to select any dams.
No,
The user can select any dam. Use the algorithms.
Was there any slide about initialization? No. Okay.
No. I think that will be also again for future exploration of what your code does. I would say that this section now.
We are new. Note that we are new in SU2.
Sure.
That's okay. It's okay.
That's absolutely okay.
That's okay.
Okay.
That's the final talk of this session.
Yes, this is the final talk in this session. So thank you all very much.